Hi and welcome back to my channel. So in this video I would like to try to measure the sensitivity of my HackRF. And so normally when you measure sensitivity in radios, you use these so-called S values from S meters that are usually included in the radios. So this is the Wikipedia page for S meter. And basically the S values goes from 1 to 9, 9 being very strong and 1 being very weak. And here you see a table of conversion. So S9 means a signal having 50 microvolts or equivalently minus 73 dBm. And all the way down to S1 we reach 0.2 microvolt or equivalently minus 121 dBm. Okay, so the idea of this experiment, I'm going to emit a signal from my signal generator, and it's going to, the HackRF is going to be at S1 or below that, so that we can measure the sensitivity of the HackRF. Now, since my signal generator cannot produce such weak signals, I'm going to produce a signal that is going to be attenuated by a chain of attenuators. So this is a 30 dB attenuator, this is another 30 dB attenuator, and finally this is a coupler, but configured this way it acts as a 19.5, basically 20 dB attenuation. Okay, so we have a total of 30 plus 30 plus 20 equal 80 dB of attenuation, and at the moment my signal generator is set to emit minus 45 dBm, so a sinusoidal wave at with strength minus 45, so minus 45 minus 40 equals minus 125, and that is below the S1 value, so it's below what is usually considered a very weak signal in ham radio. Yeah, so let me show you how the HackRF behaves with this type of signal, and here I have SDRAngle. And as you can see, as you can see here, basically we have our very weak signal. So it's basically it cannot be seen here on the waterfall, so it's very weak. But if we go just over it, it appears on the audio waterfall. So it's this line, and it's clearly visible. And so let me try to actually activate the audio. So I think I have to go here with us. Okay. So I'm not sure if you can hear. So let me actually. So let me convert this from a sinusoidal wave to basically a Morse CW message. Okay. So I can do that with this signal generator. And so I think you can hear the intermittent signal. Right. So I mean it's clearly visible on the waterfall. It can be heard by this speaker, and now it is actually clear that it appears also on the big waterfall display. So I would say that the HackRF can definitely hear signals below S1 or minus 125 dB. Right, so let me disable the audio for a second because it's a bit annoying, and let me show you so let me disable SDRAngle. Let me show you that indeed we are getting a signal, as I promised, of minus 125. For that I'm going to use my spectrum analyzer. So I'm connecting what previously was going to the HackRF to the spectrum analyzer, and let me activate here, the view. So as you can see, the spectrum analyzer is currently set at the right frequency, but it has a bandwidth of only 30 Hz. So it's the spectrum analyzer is scanning this 1 kHz span, which is very narrow, using a 30 Hz filter. So it's extremely narrow. Okay, so the sensitivity is pretty good. So As you can see now, at the moment, sometimes it gets some signal, sometimes the line is flat, and this is because the signal is intermittent, right? So let's go back to a pure sinusoidal function, and now we should see our signal there. And in fact, let me activate some averaging so we can get a better average look at what the signal looks like. And indeed, the peak is here, and as you can see here on the top, we are indeed at minus 126 dBm. So as you can see here, this is, let me see if I can display a line. This line here on the bottom is basically the noise floor of this spectrum analyzer. It's around minus 126 dBm. Let me check the current attenuation settings. Yeah, 0 dBm. So this is really the maximum sensitivity of this spectrum analyzer, and this means that yeah, the HackRF can actually hear at this same level. So let me in fact reduce as much as possible the signal that I have. At the moment here I have minus 45, which corresponds by 80 dB of attenuation to minus 125. Let me go down a little bit, so I'm now minus 50. So let me restart the averaging. Okay. Let's see. Now we should see a signal of minus 130 dB more or less, and there it is, precisely minus 130. And I'm trying to go down as much as possible as this signal generator allows, which is minus 55 here. So we should get a signal there of minus 135. Let's see if this oh sorry, I misclicked here at the moment, so I was activating the peak table, but let me disable it. Right, so I just want so let's see, so how do I go back? Wait a second, sorry. So peak search, I have to disable this peak table. Okay, go back to trace and reset the video averaging. Okay, so we can start again, and let's see if we can get our minus 135 dBm signal. It's there, as you can see. It's just above the noise floor of this instrument. Yeah, peak search, it's, yeah, minus 133, it says 34. Yeah, this is what we expect. So the noise floor is basically minus 140, which is pretty good. And now let's reconnect the signal now at minus 135 to the HackRF, and let's see if we can receive it. Let's see. Right, so let me see. Okay, so yeah, here, well, here you have now SDRAngle, and as you can see, the signal has almost disappeared. Let me reactivate again the modulation so we can have a better view, because we can see the intermittent. So on the waterfall, as you can see, we still have the information. Okay, so I think we can say the SDR HackRF is still copying this message, barely, at the level of the waterfall. Let me see if I can hear something. Yeah, an extremely weak signal. So I think this is barely copied by the HackRF, but still, on the waterfall display here, it's completely clearly visible. So I would say that the HackRF is definitely receiving this signal, even if barely. So yeah, I don't know if this is the proper way to measure the sensitivity of a receiver. This is the only test I could think of. If you have any suggestion on how to improve it and how to modify the type of measurement, please let me know, and I will try to do that. Thank you very much, and I'll see you next time. Bye bye.